So in 10.5, parametric equations, most of the things that we've talked about up to this point have talked about x and y coordinates. And so like you could look at a parabola, graph it. You could know that maybe y equals x squared, you have the 0.11 or the 0.24 or 39. In parametric equations, they add an extra piece of information. Usually, it's a time component, and the parameter is t, which stands for time. One of the things that's an advantage about that is, like, for example, when they launched a satellite into space and they were taking pictures of like Mars and Jupiter and all that kind of stuff, they could tell the exact moment that they were going to be at a certain position in space to know to turn on the camera part of that space vehicle so that they could snap pictures of the planet and not waste energy, because the battery life is only going to be so long. And so they had to make sure they knew when that was going to occur. And so they use parametric equations when they do things like that. So today we're going to kind of learn about that. Your calculator can actually do parametric equations. I'll show you how you do that as well. And so what happens is, instead of having just x and y, they'll have x equals something and y equals something. If you notice down below here, you'll see two equations. One says x equals 2t. One says y equals t squared. And then they give you an additional piece of information. They give you the stuff in the yellow highlight, which says from -2 to 5 inclusive, which is the window for t. So they don't say it specifically, but this stuff is referring to your t values. And what you'll see is that same stuff is indicated here for my table. So t is what we would call the independent variable now. And x and y both are dependent variables, which means you choose the value for t, plug it in, and out pops x and out pops y. Let's look and see what that means in our table. So if I look at the equation x equals 2t, and my x values are here in my table, and my y values are going to be here in my table. When I look at the x values, if I shove in a -2, out pops -4. If I shove in a -1, out pops -2. If I shove in a 0, out pops 0. So on and so forth. Can you guys see that red inside the red highlight? No? Okay, so that sucks. How about if I use black, like -4? Can you see that? Okay, sorry. -2, 0. What am I looking at? I'm looking at the red equation. What am I plugging in? All the yellow stuff. Shove in a 1. Hey, you get 2. Shove in a 2 and you get 4. Shove in a 3 and get 6. And then 8. And then 10. Blah, blah, blah. We can do the same thing for the blue equation. Except this time, you take the yellow stuff, the t, and you square it. So -2 squared is 4. -1 squared is 1. 0 squared is 0.
Would you add 1?
1. So my apologies, I didn't notice that we actually had +1 on the end here. So I wasn't adding 1. Thank you very much for noticing. That must have been really funny from the Giggle Girls in the back. Alright, so actually what's going to end up happening is I'll have -2 squared, which is 4, plus 1 is 5. -1 squared is 1, plus 1 is 2. 0 squared plus 1 is 1. And then I'm pretty sure this is symmetric, right? So 2, 5, 3 squared makes 10 when I add 1. 4 squared is 16 plus 1 is 17. Then 5 squared is 25 plus 1 is 26. Questions on where any of these numbers are coming from? So this t thing is the thing that we are plugging in for the t values in the blue and the red equations. It's our independent variable. Stands for time usually. It is a parameter. Let's graph it. I'm not going to do all these different points, but let's graph it. When you graph, the thing to remember is once you use the t, you ignore it for the most part. You're still graphing x and y. So here's my x-axis. Here's my y-axis. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 5, whatever. And so when I plot these points, what just happened? What just happened? Unbelievable. Okay. This is great. Boom. That didn't work. Huh? No. It's gonna be a nice long video for you guys.
Did you like DC?
Sorry, didn't know what happened. So if I'm graphing these things, what I notice is if I go out to -4, I'm at the y value of 5. So -4, 5, right about here. And then I have -2, 2. Works best when you're in ballet. And 0, 1, 2, 2. Maybe you got it that time. 4, 5. If I draw this figure, parabola, looks like this. One of the cool things that parametric equations show us is the following. Number one, I know that this location over here to the far left occurred when t was -2. I know this one occurred when t was -1, when t was 0, t was 1, and t was 2. Which also tells me that if I was looking at something in motion, that the motion is going in this direction. So the big idea in parametric equations, at least when you're using time as your parameter, is it tells you when you were at a certain location. That's kind of the best benefit of parametric equations. Questions? In number 2, they say to use our calculator. We'll do that in just a moment, but I actually want to do this by hand again, just so you can kind of see how it works out. Remember that when you're doing this, the stuff that they put in the brackets, that stuff is representing your t. And then, again, we have our x-dependent stuff and our y-dependent stuff. When I see that, I usually make a table right away. So off to the side, I'm going to go with t, x, and y. And they tell me that my t starts at -3, so I write down -3, then -2, then -1, 0, 1, 2, and 3. And this first column will be all the things that I chose for t from my brackets. And the next column will be all of my x values that pop out. And then in the third column will be all my y values that pop out when I plug in those t values. So let's say that I plug in -3 into the red equation, x equals t squared. So -3 squared 9. Negative 2 squared, 4. Negative 1 squared, 1. 0 squared, 0. And then it's symmetric, so 1, 4, and 9 as well. I can look into the blue equation, and I take whatever t value I have and subtract off 1. So negative 3 minus 1 is negative 4. Negative 2 minus 1 is negative 3. Negative 1 minus 1 is negative 2. And you can probably see the pattern as you go along. And I've filled out my table. Now once I've filled out my table, I'm going to ignore for a while the yellow column. Because the only reason I was using that yellow column, the parameter, the independent variable, was to generate the coordinates of x and y. So now I'm going to graph the coordinates of x and y. Here's my x-axis, here's my y-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so first coordinate is 9, negative 4. Don't really have enough spaces for that, but so I'll just extend my stuff over here. 6, 7, 8, 9. This is my x-axis. So 9, negative 4, if I graph that, is 9, negative 4 over here. And then I have 4, negative 3. So 4, negative 3, so right about here. 1, negative 2, right about here. 0, negative 1. 1, 0. 4, 1. And 9, 2. Is that what it says? And this is also a parabola. It's a sideways parabola. One of the parabolas we just got done talking about. You can see that the motion is in this direction. And if I wanted to name any point, like let's say I wanted to pick the point 0, negative 1, right here. And I said, hey, 0, negative 1, when did that point occur? It occurred at time equal to 0 for this point right there. So the parameter tells you when. It also helps indicate the direction. Now let's go to our calculator and try this on our calculator. So grab your calculator. Now the first thing that you have to know about your calculator that's very, very important when you're working with parametric equations is you have to be in parametric equations. So go to mode.